Hello, my amazing students. This is Mrs. A, and I'm back with 6.3, and 6.3 only has two problems. So here are the two problems on 6.3 from your PowerPoint slide. So we're going to do number 2 first, and number 2 is actually one of the problems that is on your practice test that I gave you today. This one is problem number 24 on your practice test. So I'm doing part of your practice test for you. It says the distribution of room and board expenses per year at a 4-year college is normally distributed with a mean of 5,850 and a standard deviation of 1,125. Random samples of size 20 are drawn from this population and the mean of each sample is determined. Which of the following mean expenses would be considered unusual? So then we have the 3 different ones down here that we're going to analyze and see which one is unusual or are none of these unusual. After we do this one, I'll come back and do the book problem. Okay, so we're going to do this one in a minute, but we're doing the one that was written out for you first. And I'm just going to say, okay, they did not give me any criteria for unusual, so I'm going to use our standard. If z is less than -2 or if z is greater than 2, I'm going to say it's unusual. Okay, so since they didn't give me any criteria, that's our general rule of thumb, so I'm going to use that one. Our population was normally distributed. We had a mean and a standard deviation as given of the population, and we're told that each sample is a sample of size 20. Since we know we're taking the distribution of the sampling means, we're going to use our z-score is going to be x bar minus the mean of the population divided by the sigma of the population divided by the square root of 20. Remember, this right here is the standard error of the mean. So it's our basic z-score, but now instead of mean, we're going to use instead of our regular random variable x, we're going to use x bar. And that's going to be one of these. And then instead of our standard deviation down here, we're going to use the standard error of the mean. So now what I'm going to do in the next little board, okay, I'm going to kind of work backwards. I don't want to plug each one of these things in. So I'm going to take my z equation. Z of x bar is going to be x bar, which is one of my 3 values over here. Okay, one of these 3 values, minus the 5,850, which was the population mean, divided by, now I've already gone ahead and done the math. Remember, we had the 1,125 that's divided by the square root of 20. When you do that math, you get 251.56. So I've already done a little bit of the work here. So now I'm trying to solve for what my x bar is going to be. So I'm going to let this z be either -2 or +2 because I'm trying to find what are those marks where it starts to go unusual. Okay, so I'm going to start with -2, and I'm going to multiply both sides by 251.56. So I get -2 times the 251.56 plus the 5850. I'm basically going backwards and solving for the x. All right, so I wind up, when I do that, I end up with the mark of unusual point there is 5,346.88 on the left. And then I'm going to do the same thing, but I'm going to take +2 as my z-score. I'm going to multiply it by 251.56. I'm going to add the 5,850 because it's moving to the other side. And I get the right hand most, the start of the unusual range, 6,353.12. So basically, I know that my usual means will be in between these two, where I took a z-score of -2 and a z-score of +2. Okay, so I'm back solving here. And then I look over here at these means and say which one of these means that they proposed is not in this region here. Okay, so I looked at the 6350, and that would work because it is in between the two. And then the 6180, that would work because it's in between the two. But the 5180 is to the left of 5346, and therefore the 5180 is unusual. So I hope that makes some sense to you. Okay, there was the first board, just so you can see it again. And here was the second board where I was kind of back solving to get to the X bar. Now you could have plugged each one of the X bars in and done the math, but I chose to work backwards so that I would have a region. And especially this method would be great if you were told to give the boundaries for the reasonable area, or if you were given a whole bunch, not just 3, but you were given a whole bunch that you had to do. Instead of plugging them each in, you could find the range of the where the significant values start on the left and the right. So that's the end of that problem. Now we're going to do number 11, and we will be done with this section. All right, the only other problem in this section is number 11, the sampling distribution of the sample mean. After identifying the 16 different possible samples, find the mean of each sample. So we're going to come up here, and we're going to, it says in exercises 11 through 14, use the population of 34, 36, 41, 51 of the amounts of caffeine in Coca-Cola Zero, Diet Pepsi, Dr. Pepper, and Mellow Yellow Zero. Assume that the random samples of size n is 2 are selected with replacement. Since we have random samples of size n is 2, that means we're looking for a sampling distribution of this. Okay, since we have 4 items, remember this one can be paired with those, with one of those, each one. And so we're going to end up with 16 items, okay, because 2 to the 4th power is 16. So we're going to wind up, after identifying the 16 different possible samples, find the mean of each sample, then construct a table representing the sampling distribution of the sample mean. In the table, combine the values of the sample mean that are the same. Okay, so it says, hint, see table 6.3 in example 2 on page 258. So they're giving you a hint of going back to that one to see how they're doing that. So we're going to make the sampling distribution of the sample mean of these 4 items here. And it's going to wind up being 16 outcomes that we're going to do. Then it says, compare the means of the population to the mean of the sampling distribution. And we should see that the means are the same. Do the sample means target the value of the population mean? In general, do sample means make good estimators of population means? Why or why not? Okay, so on this one, they're being kind of nice to us. All we have to do is the mean. And so that's not going to take us very much time. Hello, my amazing students. We have finished number 11. It took me a lot of work to get this on the board, but now I can show you how to do number 11 on 6.3, the only problem that you had to do in your book. Okay, so basically we set out to make the sampling distribution of the mean. Remember, we had 34, 36, 41, and 51 were the four caffeine measures for the drinks. So we were to do a sampling distribution of samples of size 2. So we started out, repetition was allowed. So we started out with 34, 34, 34, 36, 34, 41, 34, 51. Now I'm done with 34 in the first slot. So now I'm going to do 36, 36, 36, 36. And then I'm going to put 34, 36, 41, 51. And then I'm done with that. I go to 41, 41, 41, 41 with all 4. And then lastly, I do 51, 51 all the way down and all 4. Okay, so again, 16 possible combinations for the 2 in the sample. And then I went and I averaged each one of them. This is the X bar here. Okay, so in this column, I averaged the 2 together and I got each one of the means. So then I needed to make the sampling distribution. This is just my data collecting here. So then I came over here and I said, okay, each individual X bar. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 individual X bars because we had some repeats. 34 appeared only one time. 35 appeared twice. 36 appeared one time. 37.5 appeared twice, and so forth, all the way down. And then lastly, each one of these has a probability of 1/16. So I'm trying to find the mean. I multiply each individual X bar by its frequency and divide by 16. So basically this one had a probability of 1/16. So 34 times 1/16 is 34/16. 35 times 2 is 70, but that was 2/16. So 70/16 is that partial product there. And then I add all of these up together. Okay, and I did not write down what it was, but when I added them all up together and divided by the 16, I got 40.5 as the average or the mean of the sampling distribution. Okay, so this one is the mean of the sampling distribution. Well, if you take the original 4 values, 34 and 36 and 41 and 51, and you add them and you divide by 4, guess what you get? 40.5. Okay, so the mean of the original 4 numbers is 40.5, and the mean of the sampling distribution is 40.5. So the question was, is the sampling distribution mean a good estimator of the population mean? And yes, indeed it is. Okay, so this is what the book gave you here, other than showing you this. It says the mean of the population is 40.5, and the mean of the sample means is also 40.5. That was the B portion. And then the C portion says the sample means target the population mean. Sample means are good estimators of population means because they target the value of the population mean instead of systematically underestimating or overestimating it. So let me hold that as close as I can without the shine on it. Okay, so you can see the whole board. That was the work for number 11. I'm going to hold just a little bit closer, and I'm going to let you see up close what I've done, and then I'm going to move it up a little bit so you can see the bottom half of the board. I just want to make sure everybody can see how to do a sampling distribution. Now this one was only the mean. We didn't have to worry about the standard deviation. So although this was a lot of work, it could have been worse, right? We could have had to find the mean and the standard deviation, but this one was just the mean. And we're done with 6.3. And then we're moving on to 6.4, and then you'll be all ready for your test. And this is Mrs. A, and may God bless your day.